So leaving Harvard, I built out another robotics company. And that is a robotics company that is really focused on the mechanical engineering and materials of the gripper. And that was in a case where the Amazon problem, a variable size, weight, shape needs to get into a box, infinite number of SKUs. For Root, it was the exact inverse problem, which is a tomato is a delicate object, but it's not like one tomato is going to be the size of a grape and then one next to it's a basketball, right? Like it is reasonably regular. You need to have a lot of experience in how to grip. And that's something I've built over a long career in doing this. But really the new challenge was the artificial intelligence. And until recently, it just wasn't doable. Both the massive advances in convolutional neural networks and their applications to computer vision, that was enabling. The fact
Explain that for a second. Unpack that. What does that mean in plain English to a neophyte?
The modern world of computer vision is really robust in that you're creating these training data sets. You're taking photographs of an environment. You are annotating. You're circling the objects of interest. Let's say you're looking for cars. You're circling images of cars. And you're feeding those images where a human said where the cars are into a complex statistical model that teaches itself what are the fundamental attributes of cars. And if you put unoccluded images of cars, it's just easy to see whole car, it will find whole cars. If you add to that data set semi-obstructed views of cars, it'll get good and it'll start to understand how to also find semi-obstructed versions of cars. If you take a look at some of the older versions of computer vision, where it was really top-down creation of the different filters that found objects, they just would easily break down in practice in complex environments. So they were really good at, if I needed to pick an object off of a conveyor and put it in a box, and it was a well-singulated object, it had nothing else around it, it was up against a simple background, it was a white conveyor, you could, and maybe it had a logo on it where you had the ability to look for the lettering, you could take that previous generation of computer vision and make it work in that application. But you throw a pile of those objects into a bin and it's many different objects, and suddenly the environment is hyper complex, and those vision algorithms, the older ones, would fall apart. The modern generation of computer vision that everyone's talking about is able to take on highly complex real world applications, and it's quite remarkable. I would say that another major thing that has changed is being able to have computers that you can use at the edge. So when you're in a farming environment, you're, first of all, usually far away from Wi-Fi. You're far away from it's not like you're going to plug into a wall jack, right? You're often surrounded by plants, which have a way, all the water content in those plants also have a way of blocking signals. So the concept of like, I'm going to take an image at the robot, I'm going to pass it to a computer in the cloud, and I'm going to run a model, that is not, for the most part, a tractable solution for real-time artificial intelligence required for picking. The fact that I can buy system-on-module computers with chips designed for running these models, and they barely consume any electricity, super important for a mobile platform. And I can just buy these things, they're cheap, and I can put them into my robotics platform. That's a complete game changer. It's one of the reasons why you're seeing autonomous driving become ever more practical application of artificial intelligence.
That is the reason why we're seeing a lot of hardware being put at the edge of compute platforms. We had a company on the program that was building cameras for checkout lists shopping, and there are people making cameras with graphic cards in them or putting racks in the back of the stores so that they can do that computer vision in real time. And that all comes from gaming, correct? If the gaming cards had not been 60 frames, 120 frames per second, and that increasing crazy resolution, we would have never had these NVIDIA cards or whatever cards to be able to do this, correct?
It's funny because where I started to experience those graphics cards was early in my career, when at a point in life where I was very misguided and I wanted to be an academic. And I was doing a lot of spectroscopy and protein biophysics. And all of a sudden, there were a couple of really brilliant groups that realized you could start running a lot of hardcore physics on PlayStations. And then you started slapping together a bunch of PlayStations. You had a supercomputer, and it was earth-shattering. And that was in my old field a million years ago. that same kind of aha moment that it's a fundamentally different kind of chip in the way it runs these calculations in there, and the kinds of math that you do for artificial intelligence is really well mapped to those chipsets. It just makes everything move bleeding fast.
And now you have the economic incentive of cryptocurrency and Bitcoin and hash. Is that compounding at another level that people are buying all these cards to do that?
I love the fact that people are doing all of these custom chip projects and that we're getting ever more specific kinds of chips for running different parts, different kinds of important calculations that you would find on a robot. But yeah, the other applications you're talking about as well, being able to run that all at the edge with very little data passed along, like a sparse amount of metadata passed along to the cloud or passed along to a user, it allows you to put these algorithms in places where they touch the real world and solve dramatically more interesting problems, or at least more interesting to me.
Every startup needs business insurance, and you should look no further than my friends at Embroker. If you don't have insurance, you failed one of the first steps of being a great entrepreneur. Embroker's technology saves you time and money. Prices are up to 20% lower with better coverage than the incumbents, and you can go from sign up to quote and purchase in just 10 minutes. And trust me, I've been through this for 3 decades of getting insurance. I'm getting old here, folks, and Embroker is quick, easy, and affordable. And there's 4 types of insurance that are critical in the startup space. I know these like the back of my hand because I'm on the board of companies and I see when things go wrong and I see what the insurance can do in terms of decision making. Cyber insurance, super important. Unfortunately, because things are getting hacked constantly. D&O insurance, that's if your directors and officers, board members, your senior employees do something dumb and you get sued. Let's leave it at that. And E&O, that covers errors and omissions, and that will help you scale because any major customer will say, do you have E&O? If you want to close a deal. And finally, EPL, employment practices liability. This covers harassment, wrongful termination, and more. So to instantly buy custom-built insurance for startups, go to embroker.com/twist, embroker.com/twist. While you're there, you get an extra 10% off if you use the offer code TWIST. Please put in the offer code TWIST so they know that I sent you. Okay, let's get back to this amazing episode.